Hello students, welcome you all to the video session on Module 5 Joint Probability Distribution and Sampling Theory of the subject 18MAT41 Complex Analysis, Probability and Statistical Methods. So in the previous video sessions on Module 5, that is Joint Probability and Sampling Theory, we have studied the joint probability distribution and solved related problems, and we have also studied the basics of sampling theory and solved few more problems. So today in this video session I will be discussing about students T distribution. So this students T distribution is a theoretical distribution which is used to test the sample mean of a small sample which is drawn from normal population. So this T distribution is a theoretical distribution which is used to test the sample mean which is of the sample which is drawn from a normal population. So here I have given in detail, it is to test the significance of a sample mean of a sample which is drawn from a normal population. Now here the variate T is given by x bar minus mu divided by S into root n. X bar minus mu divided by S into root n. What is x bar here? X bar is equal to mean, that is sigma x by n, mean sigma x by n, and mu is the population mean. Mu is the mean of the population. X bar is sigma x by n, and here S square is calculated by using the formula S square is equal to 1 by n minus 1 into sigma x minus x bar whole square. 1 by n minus 1 sigma x minus x bar whole square. So S becomes the root of S square. So using this data you calculate what is T. We need to test the hypothesis whether the sample mean x bar differs significantly from the population mean. We need to test the hypothesis here whether the sample mean x bar, the mean of the sample is taken as x bar and population mean is mu. We need to test whether the sample mean differs significantly from the population mean, for which you calculate the parameter T, and based on the value of T you make the conclusion. So how do you make the conclusion? If the calculated value of T is greater than the table value of T, say T of 0.05. So here, as I told you in the previous test, you can also take mod T. Instead of T, you take mod T. If mod T is greater than the table value of T, say T of 0.05, we say that the difference between x bar and mu is significant at 5% level. T of 0.05. So like a normal distribution table, standard normal distribution table, you have T distribution table. Either you have to refer the T distribution table to get this value, or this value will be given in the problem most of the time. Okay. If the calculated value of T or mod T is greater than the table value of T 0.05, then we reject the hypothesis. We say that the difference between x bar and mu is significant at 5% level. T of 0.05 stands for 5% level. If it is greater than T of 0.01, the difference is significant at 1% level, and you reject the hypothesis. So remember here, like the previous test only, this is if mod T, the calculated value of T, you take the modulus of that. If it is greater than T of 0.05, we reject the hypothesis at 5% level. If it is greater than T of 0.01, you reject at 1% level. Reject the hypothesis if it is greater than. Okay. And In all other cases, we accept the hypothesis. If the value of mod t is less than t of 0.05, we say that there is no significant difference between x bar and mu at 5% level. Similarly, if mod t is less than t of 0.01, there is no significant difference at 1% level, difference between sample mean and population mean. Okay. Test of significance of difference between sample means. How do you test the significance of difference between sample means? Suppose you are given two independent samples, x1, x2, x3, etc. xn1. That is, the first sample contains n1 members, y1, y2, etc. yn2, n2 members, with means x bar and y bar. Mean of the first sample, let it be x bar, and mean of the second sample is, say, y bar. And standard deviations, say the standard deviation of the first sample is sigma x, standard deviation of the second sample is, say, sigma y. These are drawn from a normal population, that is, from a population which follows normal distribution and both has the same variance. Then we have to test the hypothesis that the population means mu1 and mu2 are the same. You have to test the hypothesis that the population mean mu1 and mu2 are the same. Okay. Now here given two samples, the first containing n1 elements, second containing n2 elements. We need to test whether the population means mu1 and mu2 are the same. Now, for this we calculate t. The variate t for this is defined as the difference between the means, sample means, x bar minus y bar or y bar minus x bar. It's one and the same, because finally we are taking the mod here. T is equal to x bar minus y bar, or difference between x bar and y bar, divided by sigma root of 1 by n1 plus 1 by n2. Okay, you have two samples, so it is 1 by n1 plus 1 by n2. Whereas in the previous case we have considered here 1 by n square, root of 1 by n, root of 1 by n. So you have considered root n here. But here two samples, 1 by n1 plus 1 by n2. What is x bar? Mean of the first sample, summation xi divided by n1, number of elements. Y bar is summation yi divided by n2. And here sigma s square. Sigma s square is 1 by n1 plus n2 minus 2 into n1 minus 1 into sigma x square plus n2 minus 1 into sigma y square. Or alternately, the easiest formula here is 1 by n1 plus n2 minus 2 into sigma xi minus x bar whole square, summation from 1 to n1, plus summation yj minus y bar whole square, summation from 1 to n2. Now here you can observe the easiest way to remember the formula is you remember this alternative formula rather than this. In the previous case you have calculated s square, right, 1 by n minus 1 into summation x minus x bar whole square, right. You had only x there, but here you have x and y both, so you are calculating the summation of both, and here you have, instead of n minus 1, n1 minus 1 plus n2 minus 1, so it is n1 plus n2 minus 2. So this variate defined by 1 follows a t distribution with n1 plus n2 minus 2 degrees of freedom. n1 plus n2 minus 2 degrees of freedom. So what is now this degrees of freedom? So I have given the definition here. The degrees of freedom, shortly denoted as DF. It is the number of values in a set which may be set arbitrarily. Suppose you have 3 numbers in a set, x1, x2, x3. Any 2 numbers you can give arbitrary value, and the remaining one number can be written in terms of x2 and x3. So if you have n number of observations, the degree of freedom is n minus 1. Right? And if you have n minus 1 number of observation, the degree of freedom is n minus 2, and so on. If you have n minus 2 number of observations, the degrees of freedom is n minus 3. So here how many number of observation? In case of first, it is n1. So n1 minus 1 degree of freedom, plus here n2 minus 1. So it is n1 plus n2 minus 2. So remember the variate C. And here the same way you calculate the test of significance. If the calculated value of t, or in fact it is modulus of t, is greater than t of 0.05, the difference between the sample means is said to be significant at 5% level of significance, same as that of the before. If it is greater than t of 0.01, the difference is significant at 1% level of significance. Testing the hypothesis, comparing the values is the same. And if t is less than t of 0.05, the data is said to be consistent with the hypothesis, that is mu1 is equal to mu2. What was the hypothesis here? We have to test the hypothesis that the population mean mu1 and mu2 are the same. Right? If t is less than 0.05, the data is consistent, that is population mean mu1 is equal to mu2 at 5% level of significance. If t is less than 0.01, the difference, there is no significant difference, and we say that mu1 and mu2, right, at 1% level of significance. Okay, we will consider a few problems here. A machine is expected to produce nails of length 3 inches. A machine is expected to produce nails of length 3 inches. A random sample of 25 nails gave an average length of 3.5 inch with standard deviation 0.3. Can it be said that the machine is producing nails as per specification? Can it be said that the machine is producing nails as per specification? Given the value of t 0.05 for 24 degrees of freedom is 2.064. You have a random sample of 25 nails. So number of elements in the sample is 25. So degree of freedom is 24. So t of 0.05 for 24 df is given here. So what do you have from the table? What do you have from the given problem? Mu is equal to 3. A machine is expected to produce nails of length 3 inches. A random sample mean is 3.1. So x bar is 3.1. Average length is 3 inches, that refers to your population, but x bar is 3.1 for the sample. Standard deviation is 0.3. So S is also given here. No need to calculate S. S is given 0.3 and N is equal to 25. So use the standard variate formula. T variate. T is equal to x bar minus mu by S into root n. X bar is 3.1, mu is 3. So it is 0.1 by S. S is 0.3 into root n, root 25. So 0.1 by 0.3 into root 25. Calculate the value. It comes as 1.67. So your calculated value of t is 1.67, but what is t of 0.05 for 24 df? 2.64. Your calculated value of t is less than your table value of t. So what can you say? You accept the hypothesis that the machine is producing nails as per specification at 5% level of significance. Okay, the machine is producing nails as per specification is accepted at 5% level of significance. Okay, consider one more problem wherein you need to calculate yes here. 10 individuals are chosen at random from a population and their heights in inches are found to be 63, 63, 66, 67, 68, 69, 70, 70, 71, 71. Test the hypothesis that the mean height of the universe is 66. Given t of 0.05 is equal to 2.262 for 9 degree freedom. So 10 individuals are chosen at random from a population. From a population you are choosing 10 individuals, that is 10 samples, and their heights in inches are found to be this. Okay. Test the hypothesis that the mean height of the universe, that is universe is nothing but population, mean height of the universe is 66. So mu is 66 here. You assume that the mean height of the universe is 66. That is mu is equal to 66 according to your hypothesis. What is n? N is 10. 10 individuals. Sample size is 10. X bar is equal to sigma x by n. Add all this: 63 plus 63 plus 66 plus 67 plus 68 plus 69 plus 70 plus 70 plus 71 plus 71 divided by 10. Add and see. Divide by 10, you will get it as 67.8. Verify the value. It is 67.8. Now, what is S square? What is the formula you have for S square? S square is 1 by n minus 1 summation x minus x bar whole square. 1 by n minus 1 summation x minus x bar whole square. What is 1 by n minus 1? N minus 1 is 9. So 1 by 9. Your x bar is 67.8. So x minus x bar whole square for each x and then summation. So what is x minus x bar whole square? 63 minus 67.8 whole square plus again 63 minus 67.8 whole square plus 66 minus 67.8 whole square plus 67 minus 67.8 whole square and so on. Okay, x takes values 63, 63, 66, 67 and up to 71. So for each value of x here, you calculate x minus x bar whole square and add it up. Okay, for each x, you calculate x minus x bar whole square and find the summation into 1 by n minus 1 or divide by n minus 1, that is 9. Calculate, you will get it as 9.067. 9.067. So what is your S? S is equal to root of 9.067, that is 3.011. So using these values, you find T T is equal to x bar minus mu by S into root n. So x bar is 67.8, mu is 66, S 3.011, root n, root of 10. That is equal to 1.89, which is less than the given tabular value. The calculated value of T is less than the given value of T, 0.05. So what can you say? The hypothesis is accepted at 5% level of significance. This is T of 0.05. So hypothesis is accepted at 5% level of significance. Move to the next problem. A certain stimulus administered to each of the 12 patients resulted in the following change in blood pressure: 5, 2, 8, -1, 3, 0, 6, -2, 1, 5, 0, 4. Can it be concluded that the stimulus will increase the blood pressure? Now, T of 0.05 is given, 12 patients, DF is 11. X bar, calculate, add all, divide by 12. So x bar is 2.5833. So S square is 1 by n minus 1 into summation x minus x bar whole square. So for each value of x, you calculate x minus x bar whole square and add it up, or you can use this formula also, but I prefer you follow the same formula, otherwise you may get into confusion. Whichever you prefer, you can use. So for each x, calculate x minus x bar whole square. X is 5, so 5 minus 2.5833 square plus 2 minus 2.5833 square and so on. You get it as 9.538. So what is your S? S is 3.088. S square is 9.538. So S is 3.088. Okay. Now what is the question? Can it be concluded that the stimulus will increase the blood pressure? Can it be concluded that the stimulus will increase the blood pressure? So what is your hypothesis? You assume the hypothesis that stimulus will not change the blood pressure. The stimulus given to 12 patients has changed the blood pressure as follows. Now your conclusion is regarding the entire population or the universe. You are assuming that the stimulus will not change the blood pressure. That is mu is equal to 0. Okay, mu is equal to 0. So T is equal, we have T is equal to x bar minus mu by S into root n. Let us suppose that the stimulus does not change any increase in the blood pressure. So take mu is equal to 0. So T is equal to x bar minus mu by S into root n. X bar is 2.5833 minus mu is 0 divided by S, that is 3.088 into root n, that is root 12. So when you calculate, you will get it as 2.8979. 2.8979. So calculated value of T is greater than the tabular value of T. The tabular value of T is given in the question, right? T of 0.05 is 2.201. So calculated value of T is greater than the tabular value of T. So you can say hypothesis is rejected at 5% level of significance. Hypothesis is rejected at 5% level of significance. So we conclude with 95% confidence that the stimulus in general is accompanied with increase in blood pressure. So at 5% level of significance, the hypothesis is rejected. So we can conclude with 95% confidence, not with 100% confidence. The hypothesis is rejected at 5%. So with 95% confidence, we can say that the stimulus is accompanied with increase in blood pressure. The stimulus always increase the blood pressure because hypothesis is rejected. You have one more problem here. Two types of batteries are tested for their length of life and following results are obtained. Battery A, N1 is equal to 10, X bar 500, sigma square 100. Battery B, N2 is 10, X bar 560, sigma square 121. Find students T and test whether there is a significant difference in the two means. You are given two samples. The first sample consists of 10 elements. Mean is X bar 500. Standard deviation or sigma square is 100. Here N2 is again 10. X bar is 560. Sigma square is 121. Okay. Find the student T. What is student T here? Student T is given by, when you are given two samples, x2 minus x2 bar minus x1 bar or x1 bar minus x2 bar, one and the same, divided by s into root of 1 by n1 plus 1 by n2. You know what is x1 bar, what is x2 bar, it is already given in the question. You know what is n1, what is n2. You can calculate s by using the formula. This formula I think I had not given, so note down this formula. When the variance is given, you can find s square by using this formula. Note down the formula. S square is equal to n1 sigma 1 square plus n2 sigma 2 square divided by n1 plus n2 minus 2. So s square is equal to n1 into sigma 1 square, that is 10 into 100 plus n2 sigma 2 square, again 10 into 121 divided by 10 plus 10 minus 2. Degrees of freedom 9 plus 9, that is 18. So calculate, you will get s square as 122.78, so that your s is 11.0805. S is 11.0805. So what is your T? Substitute here. T is equal to, the difference between the means 500 and 560 is 60 divided by S, that is 11.0805, root of 1 by 10 plus 1 by 10, that is 0.1 plus 0.1. Calculate, your T is 12.11. Your T is 12.11. This value of T is greater than the table value of T for 18 degree of freedom. So you need to find the table value of T. So it will be given in the problem, but here it is not given. Okay, you need to verify, you need to find what is the table value of T distribution table you see. And maybe in the next video I will tell you, I will give you the T distribution table and tell you and explain you how to find T of 0.05. Okay, this value of T is greater than the table value of T at all levels of significance. Level of significance is not mentioned in the question, so you can check for both level of significance. Therefore, the hypothesis that there is no significant difference in the two means is rejected at all significant levels. So this value of T is greater than the table value of T. So you are rejecting the hypothesis that there is no significant difference in the two means at all significance levels. So your null hypothesis is rejected. So you are always assuming that there is no significant difference between the two means, that is mu1 is equal to mu2, so that hypothesis is rejected now. You have one more problem here. Two horses A and B were tested according to the time to run a particular race with the following result. Two horses A and B. Test whether you can discriminate between two horses. The time needed for the horse A and horse B to run a particular race. Here t value is given already. Let the variables x and y respectively corresponds to horse A and horse B. What is x bar? X corresponds to horse A and y corresponds to horse B. X bar is equal to sigma x by n1. So add all divided by 7, that comes as 31.3. Y bar is sigma y by n2, 169 by 6, that is 28.2. So x bar, y bar you have calculated. You need s square. What is s square? 1 by n1 plus n2 minus 2 into summation x minus x bar whole square plus summation y minus y bar whole square. Okay, this I have calculated separately here and written the value. You just write down all the values, calculate, simplify and verify your value. X minus x bar whole square. X bar is 31.3. So what is x minus x bar whole square? Corresponding to each value of x. 28 minus 31.3 whole square plus 30 minus 31.3 whole square and so on. Okay, find the summation, substitute. So s square will be, what is n1 here? n1 is 7, n2 is 6, so 13 minus 2, that is 11. So s square is 5.2973, or s is square root of that, that is 2.3016. So what is your t? T is x bar minus y bar divided by s into root of 1 by n1 plus 1 by n2. X bar 31.3 minus y bar 28.2 divided by s, just now you calculated 2.3016 into root of 1 by 7 plus 1 by 6. Calculate this value, that is 2.42. The calculated value of t is 2.42. But given in the problem, t of 0.05 is 2.2, t of 0.02 is 2.72 for 11 degree freedom. This value is given in the problem. So your calculated value of t is less than t of 0.05. Sorry, calculated value of t is greater than t of 0.05 but less than t of 0.02. Calculated value of t is greater than t of 0.05 but less than t of 0.02. So hypothesis is rejected at 5% level of significance and accepted at 2% level of significance. Okay. What is the hypothesis you are going to take? Always you are assuming the null hypothesis. That is, there is no difference between the two horses. There is no difference between the sample mean. There is no difference between any two characteristics. So your assumption is there is no difference between the two horses. So at 5% level of significance, the difference, discrimination between the horses is significant. There is a significant difference between the two horses. That is your null hypothesis you are rejecting. Null hypothesis is there is no discrimination between the two horses. So you are rejecting at 5% level. but not at 2% level of significance. At 2% level of significance, there is no difference, no discrimination between the horses. So you can say with 95% confidence level that there is significant difference between the two horses. But at 98% confidence, you can say that there is no difference between the two horses.